information, and even if it's supporting a implementation, it has to be necessary to know what are the borderlines in making the changes, because we can't just take the implementation of VM, for instance, as such and start running it. We really have to modify it to run properly in the device. Then one note is to note about the role of the Java, and it's kind of also making a point. It might be actually in the background section and not in the requirements. It's that it's mainly used for portability between the devices. It's portability between the manufacturers. It's portability between whatever. So that's one important aspect of being virtual in here. The other thing is that it is being isolated from the rest of the device, and that's why it was kind of interesting to hear these discussions where the borderline between operating system and star whatever it is. There's actually a purpose of being isolated, because we are talking about consumer devices and not necessarily computers. So the basic functionality, phone being a phone and functioning as a phone, regardless of what you are installing there, is important. And the other side is that it actually makes the development easier. There has been cases like for us, that people have been using the Java to implement something that could have been implemented in native, and it has been much more productive. One of the reasons is that, of course, that the Java is usually a more productive language. But the other side is that the developer do not have to know about all the underlines, just about the things that they needed for the development. So it's really important to understand that it's virtual execution environment in that respect as well. Then the execution speed is interesting. Of course, as an introduction, the fast response is assumed. So the hourglass type of behavior is not really for anything else but PC users. And then, of course, when I've been talking to Java and putting Java in a phone, people are first interpreter. It has to be very, very slow. And then it's very easy to show counter example of having rather complex algorithms run in real time in a phone in a bytecode execution. It runs reasonably fast. And I haven't been hearing that much complaint about the bytecode execution speed. The complaints are more about graphic speed, startup times, sometimes garbage collector pauses, and things like that. Of course, there will be a day when the applications are more challenging. But at the moment, I don't think that the bytecode execution is a bigger thing. So the already seen technologies are quite interesting. One note, of course, is this hardware versus software acceleration. I guess in desktop or servers, nobody is really talking about specific Java processors, and in that world, it's easy to say that what happened to the list processors. I don't know too many of people remember those anymore. RISC processors came and made it obsolete. One could, of course, argue that why we should have specific Java hardware either. But in this embedded world, it's still being discussed, and I guess the main argument is that the software, like JIT type of acceleration, is about trading between the memory and speed. And with hardware ones, you don't have to trade the memory. Memory footprint is another thing. All the memory footprint expanding, and memory, also available memory in the device expand. It will still stay a problem. It's not actually growing as fast as in late desktop. Thank you. It's also that in many of these virtual machine technologies, like Java technologies, things are inherited from the computer. Thinking is inherited from there. So the design is not really optimized for minimal footprint. And that's not kept in mind, so sometimes the results are different. And also in these devices, one has to remember that there's two types of memories. It's storage of flash memory and then the RAM. And also different devices have a little different memory configuration, and that also affects on how you should plan and how you should design your system. And then the praised metadata is of course, we all know that Java metadata is used for many good things. But when you have to care about every single kilobyte and you find out that the effective bytecode is only 20%, and you talk about your colleague that designed the device, what is I need this 80% of the application just for simple tables and all kind of stuff there. And the other thing is that the standard Java application packaging contains multiple copies of the same data, as we all know. So that the even simple application has several occurrences of Java lang object and stuff like that. And one thing that I added based on yesterday's discussion was this dynamic compiler. There was discussion that the bookkeeping for finding the hotspots would be the killer for embedded devices. Could be. I'm more like suspecting that the problem is more on in addition to recognizing hotspots, recognizing the cooling down fast enough. We have been doing and have been doing also quite a lot of experiments on this the hotspot type of compilers in a device, and it seems that the problems occur when you have too little memory to keep the bytecodes or compiled results of bytecodes in the memory, and you have to throw them away. And if you happen to throw the wrong method away and then recompile, actually that is killing the performance badly. So I guess the one input would be finding good ways to recognize that which code could be thrown away immediately. And I guess the one rule of thumb is that compared to many other environments, it's not possible enough that you're throwing them away when the application execution ends. You actually have to find something to throw away in the middle of the application quite often. Okay, one interesting thing that could be, of course, thought is that yesterday we discussed about this having several cores in the same CPU. But when I've been talking to my hardware colleagues, they are actually talking about having dedicated accelerators. The graphics accelerators are the most obvious ones. And that's somewhat different. And one challenge is how to use the VMs to abstract that. How to make a VM that takes an advantage of these accelerators and make still one nice, simple interface for the programmer to use. So I would kind of leave that as one research science. One user interface is I'm considering the user interface part of this equation, and it's the one reminder is that I'm always making that embedded devices are not PCs. At the same time, the criticism I'm hearing about MIDP is that the API is so different from what everybody is used to. And when I go to people who are concerned about phone user interfaces, say that no, the ideas that are based on AWT, Swing, or SWT, or whatever they are, do not actually match. And this is a nice, interesting dilemma. And the challenges there are how to manage the variations of the input devices and screen sizes and shapes. And one additional point is that how could we, and how much we could assume that developer is coping with the difference.